Hey guys, I'm Scott Carline here at Axleboy Offroad, and today we're just going to kind of do a little overview of a class that we typically do live, but with COVID we've kind of been doing it recorded here and there, so we thought we'd put this presentation together and see what we came up with. So seriously, you guys are going to hear me talk a lot about Jeeps, and I just use the word Jeep fluently back and forth, and that's because that's my passion. But I want to make sure that everybody understands that Axleboy Offroad is not simply a Jeep shop. We're fluent in Toyotas, we're fluent in GMs, we're fluent in Fords. We work on all SUV light truck platforms, and we can modify them for off-roading or overlanding or whatever happens to be the case. So we call this class the Jeeping 101 or Off-Roading 101, and usually the part that I talk about is the modified Jeep. So what I'm going to cover today is some things like tire sizes and styles, lift kits, ring and pinions, gears, lockers, recovery equipment, things like that. But first, let's talk a little bit about me. I got my start in Jeeping in 2003 when a friend of mine bought a Rubicon, took me off-road. I'd been a Jeep dealer mechanic for years before that. First time I got off-road, I got bit by the bug, and then I spun off Axleboy Off-Road in 2004. Ever since, we've been building Jeeps every single day. I've got 32 years of experience in the automotive industry as a mechanic, as a manager, and as an off-road engineer, if you will, building and designing different Jeeps to fit the customer's needs. I've got a little bit of an addiction with training and certifications, and I'm certified in just about everything that ASE has to offer, as well as being a Daimler Chrysler Gold certified technician. So one of the first things I like to talk about when we talk about the modified Jeep is how do you research your decisions? There's just so many things out there. You can research in a magazine, but you gotta ask yourself, how do you know if they're qualified? Because really, magazines are out there, and their sole purpose is to generate income by advertising for manufacturers. So is it really realistic to think that they're going to give you a non-biased opinion from a manufacturer that's paying thousands and thousands of dollars to advertise in their magazine? Well, probably not. It's probably not in their best interest. So we have to ask ourselves, is this really where we want to get all of our information from? Or are they just going to kind of go with what the manufacturers pay them to go with? And I suspect most of the time it's the latter. The Jeep lifestyle forums, are they reliable? Maybe, maybe not. It's not hard for manufacturers to plant people in the online forums to talk up certain products, provide peer reviews to give reviews and things like that. There's some other magazines out there, these periodicals, Way of Life, JK Forum, JP Magazine. All of these people, they generate their money based off of advertising dollars. So again, they're more likely to push the companies and the products they're being paid to advertise. Another thing I like to talk about is the Amazon reviews. I like to talk about the Amazon reviews because quite often those are inflated and not really accurate. The Amazon reviews are amazing, but the product is $300 below market value. You have to ask yourself, is it really that amazing? Are those reviews real? They might be verified. Perhaps. One of the tactics that Amazon salespeople use is to give free products in exchange for a good review. After you've got 10,000 good reviews, everybody thinks it's gospel. Nobody started complaining because what the heck, they didn't pay for it, so no problem. I question. Another one that we commonly see is, well, I talked to this guy. He builds rock bouncers. He knows about Jeeps. He probably knows how to make my Jeep drive good on the highway. He probably does know about Jeeps. He probably has been there. He could probably tell you how to build the most awesome off-road machine. But what I want to ask you is this. Has his rock bouncer ever done 75 down the highway and had to make an evasive maneuver? Probably not. Has it had 800 horsepower bouncing off of rocks on the rev limiter? Every day. I just don't think that those are handled the same way. Understanding how a vehicle is reliable, understanding how it handles emergency maneuvers, highway maneuvers, parking lot maneuvers, these things don't generally come into play. So just because a person knows about a rock bouncer doesn't mean they're going to know about a dual-purpose Jeep. So we usually start off the Jeep as in terms of designing and figuring out how you want to modify it. We usually are going to start off with tires. And before we do that, I like to ask a lot of questions. So what are you going to use the Jeep for? Is this going to be your daily driver? Is this going to get you to work, going to the grocery store? Is it strictly off-road? Is it something in between? Most of us are in between. We probably spend 70% of our time on the road, 30% off-road. And yet we always want to compromise for that off-road ability. Another thing to think about is what's your total budget? How much are you really willing to spend to get what you need? Larger tires, people tend to want the biggest tire they can get. Every time you go up a size in tire, you go up in cost. You go up in needed modifications to support the additional weight and traction. Certain brand names can carry a premium price, and how does that figure into the equation? As we're starting to choose the types of tires that we might want to put on our Jeep, we have to understand how each tire is designed. The all-season tire is what most of our Wrangler Sports and Saharas come with. And this tire has a lot of rain siping. It's very quiet on the highway. It has low drag and low resistance. It gets better gas mileage. But when we get off in the mud or we get into some of the loose aggregate, we find that they're going to slip and they're not going to be worth very much. If you head into a muddy field with a set of all-season tires, you're probably not going to get out on your own. The next step up in tires is going to be the all-terrain tire. Now, an all-terrain tire is generally designed to be just as friendly on road as it is off-road. And this tire is going to be pretty quiet running down the highway. We're not going to hear a lot of howl or tire noise from it. We're still going to get mileage ratings where we can say, yeah, this is a 55,000 mile tire. I expect if I maintain it, I can put at least 50,000 miles on it, possibly even have a tread wear warranty. It's going to be good in the snow and the rain. It's going to handle those conditions good. It's going to be decent off in the loose gravel and on the dirt. It'll be okay in the mud, but without the large lugs that are needed to clear out the mud, sometimes they can lack a little bit and get packed. In general, the all-terrain tire fits most people's needs as long as they're not planning on being in mud. I think the most common tire that we see in our dual-purpose Jeep is the what I would call the mud terrain tire, the MT tire. This is going to perform pretty decent in the rain, on the rocks. We're going to get decent snow. We do have a little bit of rain technology, although not as much. Now, the drawback to this tire is that we're going to have some drag. We're going to lose a little bit of fuel economy. Our rolling resistance is going to increase. We're also not going to get a mileage warranty or a mileage expectation. So it's kind of like you buy it, you get what you get, you hope for the best. Not to say that they're not going to last 45 or 50,000 miles, just that they generally are going to wear much faster. We're going to pick up a little bit of road noise. We're going to have some humming. The distance and the voids of the tire is where we're going to get that noise from. They do have some good technology now, such as asymmetrical tread design, which helps cancel out noise, but in general, we can expect this to create a little more volume going down the highway. So I wanted to showcase two different styles of tire. The average mud terrain, this happens to be a Falcon Wild Peak MT, and then an all-terrain, which happens to be a Falcon Wild Peak AT3W. If we compare the two tires, one of the first things that we notice is that the mud terrain has a much larger lug on the side. And this is going to give us more grabbing capability over obstacles. It's also going to give us a wider area to eject and push mud out and clear the tire out. Now, we do have a little bit of lug space in this all-terrain, but not overly, not too much. This one isn't going to clear out the mud as much. This is going to pack. We also can take a look that the all-terrain tire has a lot of small cuts in it. Now, these little cuts are called siping, and this is what gives us our traction in wet and snow. Now, our mud terrain tire didn't forget us. It's still got some siping in there, just not nearly as much. Every time we have an edge like this, we have the potential for noise. So as you can see, the mud terrain's spread out a lot more. The all-terrain is a lot tighter of a pattern. This is going to keep our noise down. This is going to keep it from singing on the highway. This is going to give us edges to grab onto large obstacles and get through the rocks and the mud. Another type of tire that I want to talk about is a dedicated off-road tire. This is going to be a very aggressive tire, huge voids in between. Typically the compounds that the rubber are made out of is going to be really soft. And this is great for things like rocks and boulders and getting out there and doing some serious crawling. The problem is it's going to wear out really fast. It's going to be extremely noisy on the highway. In general, they're not round. They're so thick and heavy. They're not going to balance well, so our comfort level on the highway is going to be considerably lower. Now, if you're building a trailer rig, I think it's a great idea. If you're just going to go out and you're just planning on four-wheeling, then this type of tire is going to work great for you. But if you're taking the kids to church on Sunday, I think you're going to be a little bit disappointed. Before we start picking the size of our tire, we need to understand the two different ways the tires are sized. The first way is going to be what I'm going to call the P metric sizes. This is going to be using the metric system, and we're going to hear something like a 315 70 R18. Now what this means is that 315, that's the widest part of the tire at the cross section, it's called, which is the widest part, not necessarily the tread, but just the widest part of the tire. 70 is an aspect ratio, and this is a percentage. So basically what it's telling you is from the rim to the tread is 70% of that 315 millimeters. If it was a 75, the tire would be a little bit taller compared to the width. The R means it's a radial tire, and then 18, that means that's the rim size, that's the size of the wheel that we have. Now, if we look at the standard sizes, what's often known as flotation sizes or, good old American sizes, what we're gonna see there is we're gonna see a 35 1250 R18. So what does that generally mean? It means 35 inches tall, 1250 wide at the cross section. Our R is gonna mean the same thing. It's gonna mean a radial tire, and then the last number is always gonna be our wheel size. Basically, we find that these two tires are almost exactly the same. One's just looked at from a metric standpoint, the other's looked at it fractional or flotation sizes. Now, one thing to keep in mind is that no tire that's out there is exactly the same size as its advertised numbers. So what we want to look at is when we're ready to buy the tire, we want to go and look at the actual specifications and take a look and see, well, what size is this tire really going to be once it's mounted up on the recommended size rim? Quite often we'll find that 35-inch tires are really 33.9 inches tall. And so you want to make sure you look at that so that you know you're comparing apples to apples. While we're on the topic of tires, we're going to talk about airing down, it's called. So when we get off-road, we're actually going to remove some air from the tires and we're going to run them at a lower pressure. This is going to give us a much better footprint. It's going to give us more surface contact, and it's going to give the tire the ability to wrap around an object such as a boulder, just more tread to the pavement, and that's where we're going to get traction. Not to mention it's going to make our ride a lot more comfortable as we're off-road. Lower tire pressure is going to be soak up a lot of those bumps and things that'll chip your teeth, if you will. And as you can see by watching this video, that the tire literally wraps around, and it actually forms around it. It actually just completely wraps around. You can see the tire kind of collapses. This gives us so much more rubber contact that we can get the traction we need to get up over the obstacle. The next piece I like to talk about is drive axles, gears, and lockers. The drive axles are a part of the vehicle that transmits the torque down to the wheel and actually gets the power to the pavement, so to speak. This is one of the most expensive parts of our vehicle, and it's also one of the most important parts. In a perfect world, we might actually design the Jeep around the axles first and figure out tire sizes and expectations from that point, because it really is one of the cornerstones that we're going to build our Jeep from. The first thing that we like to talk about when we get to the axles is the ring and pinion gear ratio. Inside that differential is the set of hypoid gears, and we'll often hear those referred to as 321s, 373s, 456s. And what this has given us is a ratio. And when we think of this, we need to think of turns of the drive shaft versus turns of the wheel. So if we have 373s, if you will, what that means is 3.73 turns of the drive shaft to 1 turn of the wheel. Consequently, 456s would be 4.56 turns of the drive shaft to 1 turn of the wheel. Now what this is going to equate to is what RPM is our engine running at as we're driving down the road. If we numerically go higher on our gear ratio, the engine RPMs are going to be higher per mile per hour. One of the things that we fight when we build and modify our Jeep, we put a larger tire on, then we increase the circumference of the tire by increasing the height. So if our engine was designed to run at 3,000 RPMs at 60 miles an hour to get good power, good fuel economy, and decent acceleration, if we put on bigger tires, we just change that 3,000 RPMs and we drop it down to 2,000. Now, of course, this is a hypothetical number. The 2,000 RPMs is just a number I made up, but you get the idea. our engine will come out of its power range, and our side effects will be that we can't use 6th gear anymore. Or when we're on the highway and we're going up the hills, we're shifting in and out of gear, constantly hunting for the right gear. The vehicle's gonna feel heavier. Fuel economy's gonna go. It's gonna take a lot more throttle pressure to get us out there and get us moving. The only way that we can combat this is by changing the final drive gear ratio in the differentials. Another piece to talk about is the differential. Now, the word itself means or implies that we need the ability to turn the outside and the inside tire at different speeds throughout a turn. Otherwise, they're gonna scuff. So your salesman sold you a 4-wheel drive, but really, unless you bought a Rubicon, you probably got a 2-wheel drive. What I mean by that when I say that you probably have a 2-wheel drive, I mean that the power will transmit to the path of least resistance. So if we were to pick a tire up in the air, or we had one tire on ice and we had one tire on concrete, we're gonna spin the tire that's easiest to spin. Sometimes we'll get in a situation on a trail where we have very little weight on one front tire, very little weight on one rear tire. We're always gonna spin that tire with low traction, and we're never gonna wanna transmit the power down to the tire that has the traction. And that's just the nature of the beast. So what happens is that one tire picks up in the air, the engine starts to spin it freely, forward motion stops, and then you're stuck. So in this video, we can see, unfortunately, it's an imported Toyota, sorry, but that video does make a great point. You'll see that when this vehicle gets up on the obstacle, the tire picks up off the ground, it starts to spin freely, and the vehicle loses forward motion and has to back down the hill. One of the ways that the manufacturers will combat this is sometimes you can have what's called a limited slip differential. Now, this is going to use a set of clutches or a set of helical gears to try to transmit power to both tires. Problem is that it takes about 500 foot-pounds of torque to slip those clutches. So by the time we get all the weight on one wheel, we're well over that 500 foot-pounds of torque, and we'll still spin that tire up in the air. Now, it's going to be good in the mud, it's going to be good in the snow, and any of that real super slick stuff, you're going to spin both tires. So it is an improvement. But in terms of off-road crawling, when we might be lifting a tire up in the air or have all the weight on just one tire, we're probably not going to get it done with a limited slip. In this video, we can see the same exact style of vehicle that's outfitted the same way as the open differential. This one is equipped with locking differentials, and you can see that as it approaches the obstacle, it can go at it at a slow speed and it can crawl. Not a single tire spins, even though one comes up in the air. They all four turn at the same exact speed. What this does is it gives us control, it gives us safety, it minimizes erosion, it keeps us from tearing up the course, and it keeps us in control. When we start talking about locking differentials, there's two different styles that we mainly want to focus on. The first one is a mechanical locker, and this is going to be like your Detroit Easy locker or your Yukon Grizzly locker, perhaps your Powertrax lock right. With this style, we've got dog-eared teeth. I have an example of a mechanical locker here. This is a Powertrax no slip. This goes inside in place of what's called the spider gears inside of your stock differential. And as you can see, it has really coarse square cut teeth that have little dog ears cut into them. These mesh up. Now there's a set of springs that press this together. When we get to the part where one wheel needs to turn at a different speed, we actually have to ramp and dislodge and allow those teeth to spin. Here I have a similar differential that's installed, and we can see that when we start to turn it at a different speed, this is the type of noise that you'll typically hear when one's turning at different speeds, such as a slow parking lot maneuver or really tight turns. Now, there has to be a certain amount of slop to allow it to ramp up and disengage. So what we find is we're going to have better than a 1/4 inch of rotation. Now, by the time we get out on a 35-inch tire, what's going to happen is we put this thing in park and it's going to feel like it keeps rolling. And that's simply because it's traveling so far to allow that slop in order for it to work properly. And again, you can really hear the type of noise and how aggressive this is. Now the problem is those square cut teeth are spinning like that. As you're going around a turn, the second you step on the throttle, it jams back out together and it locks up. When we start to spin, you can really hear how this starts clicking. Now what'll happen is when you're in a lane changing maneuver or a slow winding turn and you step on the throttle or let off the throttle, it'll actually jam these out together, engaging your mechanical locker. Now what's going to happen is if you're in the middle of a turn, all of a sudden both tires are going to spin the exact same speed. Now what you're going to feel in the driver's seat is this. It's going to feel like you're fishtailing or like you have four-wheel steering. You're actually going to feel like the rear end is sliding over, and literally it is a little bit. It's also any play that's back there, any bushing deflection or any movement in a loose joint, it's going to exaggerate that. Now you might be able to get used to that on dry pavement, but I'd hate to think of what happens if you get in that same maneuver on icy or slippery ground. It'd be pretty easy to get yourself to spin out. So it's something to think about. We generally are not going to recommend any mechanical lockers for road usage, especially not on a daily driver. The other style of locker I like to talk about is a selectable locker. And this is commonly called an air locker or an e-locker, possibly a aux locker as well. This type of locker is going to operate exactly the same as your open differential. Selectable lockers are going to be commonly called e-locker, air locker. The air lockers use air pressure to engage. The e-locker uses a magnetic ring to apply magnetic force to draw over a locking plate. This type of differential is going to operate the same way that your open differential does when you're on the road, but a simple flip of the switch and we're going to lock both wheels together. This gives us control, so we have no side effects when we don't want them. But when we need that extra traction, a quick flip of the switch, our axles are locked together, all four wheels are going to spin at the exact same speed. One common thing that I hear all the time off-roading is, I don't need lockers, I know how to use my skinny pedal. And while that's true, momentum is what they're talking about, and that's coming at your obstacle with enough speed to keep yourself moving through it. While momentum can get us through an obstacle, it's sloppy, it's loose, and it's a little bit reckless. We're not in full control. One bad bounce and it could get ugly really fast. If we have a mechanical locker and we're able to crawl it with zero or no or little tire spin, we're in complete control. We're not going to tear up the ground, we're not going to tear up our vehicle, and we're going to be in much more control. It's going to be much more predictable. In this video, we have an example. We have the same two type vehicles. One's going at it with open differentials and momentum, and we can hear it. We can hear it bottom out and bang as it hits. And then when we watch the lock differentials go, same vehicle, same tires. No tire spin, very slow, very controlled. We're going to be protecting our investment. One important thing that I'd like you to avoid, and I'm going to demonstrate it in this video, is once the tires start spinning freely or a tire comes off the ground and starts spinning, we really need to get out of the throttle. It's any time that we have high wheel spin and sudden gain of traction that parts break. And that's how we break axles and differentials. We want to avoid that, and we want to avoid any bouncing or hopping once we gain traction. And these are things that we want you to avoid. In this video, you can see the tire lifts off the ground, starts to spin at a high rate of speed, and then as it slides back, it gains traction and stops. This is the point where parts break. The next piece to discuss is the suspension system. We have to design this, we have to fit it around the tires and how we're going to use our vehicle. So start off the same way we started with wheels and tires. How am I going to use my Jeep? Am I going to be on the road? Do I need to be able to have conference calls in my vehicles? Do I need to be able to hike the kids in and out of it? These are all things to consider. And quite often, more lift is not necessarily better. Many builds, we prefer to keep a lower center of gravity for stability and safety and handling. Getting all that extra ground clearance isn't everything. Sometimes we'll put more skid plates on it to protect the underside and just plan on letting it drag a little bit versus getting over everything without touching. These are things that we consider. So we want to start off, we want to think about our height and how we're going to use it. So besides the looks, why do we even need to lift it to begin with? In this diagram, we point out some things: approach angle, breakover angle, departure angle. Depending on our approach angle, when we come up to a straight obstacle like a ledge, we probably can't just go up it. We probably are going to slam into it. But as we lift and as we put shorter bumpers and larger tires on, we can actually get a tire up and drive up. Now, as the center of our vehicle gets over that obstacle, we start to get to what's called the breakover angle. And this is where the middle of the vehicle will high center, and drag and sometimes get you stuck. We call it turtling. You get stuck and you got 4 tires spinning because they're not on the ground. That is breakover angle. And then as we drop off that ledge, we have departure angle. And that's pretty much considered from the edge of the tires to the bumper. As we drop off a straight ledge, are we gonna land on the spare tire or are we gonna land on the bumper? This is our departure angle. And one of the ways we can increase this is larger tires, more vehicle lift. We do have some geometry issues that we need to think about. In this diagram, I show how the wheelbase will decrease as we lift our vehicle. Most of our modern Jeeps are gonna use a control arm style suspension. As the vehicle lifts up, the geometry of the control arms will pull the wheels in towards the center. And this is going to give us a lot of changes in our wheelbase, which is going to be how far apart the tires are front to back. As the suspension droops, they move to the center. As the suspension stuffs, it moves further out. With this style suspension, quite often, we can stuff one wheel and droop the other and find out that we actually have what's called flex steer, which is when the vehicle's flexed out, one tire's backward, one tire's forward, and we're actually turning. If we add control arms, we can actually push that wheelbase back out. And sometimes we can even go to a long arm suspension, which will reduce that arc of the control arm and keep that wheelbase change to a minimum. So in this diagram, we're going to show the difference between a short arm and a long arm suspension. As you can tell, our short arm, as it travels, the arc is much steeper. As it swings down and moves, we're literally going to move the tire backward. As it stuffs, we're going to move it forward. With a long arm suspension, we're going to move that frame contact point further back. This is going to change the geometry and it's going to reduce that arc. So we're not going to have that wheelbase change nearly as much. The next geometry issue I want to talk about is caster. And caster is going to be the forward to rearward inclination of the steering axis. We try to use positive caster whenever we can, as much as we can, within reason. Positive caster injects the weight of the vehicle in front of the tire. And that gives the tire a place where it wants to go. It gives it a sense of direction. If we go negative caster, we lean the axis back to where it's projecting the weight behind the vehicle. Now we have basically a shopping cart. Wherever the influence of the road pushes on the tire, it's going to follow. So we have no sense of direction. This is one of the things that we use to get stability at highway speeds. As we lift our vehicle and as the axle starts to swing down to lift up, we're rolling the caster out. And this is the reason for adjustable control arms and caster cams and things like that to help us get us back into specifications. When we're working on our lift kit, we want to look at the shocks. We want to talk about how do we get ride quality, and springs matter. Springs are a part of it. Spring rates are important. I think the biggest ride quality gains can be gotten within the shock absorber. To start off with, we'll talk about the two basic styles of conventional shock absorber, and that's going to be the twin tube, which is going to be similar to what you have on your stock vehicle. With this one, we're going to have shock oil mixed in a small cylinder and have a nitrogen charge on it. And this is going to work pretty good. We're going to have a very nice, even ride quality, possibly a little bit soft. Where the downside comes in is when we start to actuate that shock up and down fast on a washboard road, on gravel, on just general rough highway and road patches. We're going to begin to move that piston really, really fast, and that's going to mix together that nitrogen and the oil. What we do is we aerate the fluid and we experience what's called shock fade. So the harder we work the shock, the less shock action we get. But here I have an example of a twin tube shock. We have an inner piston, or an inner cylinder and an outer cylinder. So basically inside here we have a smaller piston, or a smaller cylinder that the piston rides up and down in. We have the shock oil filled up in here. We have some valving down at the bottom, and we have a nitrogen charge. So this is basically what comes on your vehicle. This is what your lower end aftermarket shocks are going to look like. Here we have a monotube shock that's what's called a piggyback shock. The entire housing is actually the cylinder, so we can fit a much larger piston. We've got our shock oil down here underneath the piston. We have a port that travels over to the reservoir. Then we have what's called an internal floating piston. Now this is going to separate the gas charge and the shock oil, so they're never mixed together. Now what happens is we increase the pressure by moving the shock down. It comes up, it presses that internal floating piston into the nitrogen charge, and then that gives you your shock dampening. Now one of the other great features about this style of shock is as the temperature begins to increase, because you're using it much heavier, you're going much faster, going over those gravel roads, the pressure inside changes directly relative to the temperature. And so the harder we use the shock, we have dynamic ability where the pressure increases, we get more shock action. So instead of shock fade like we get with this guy, where it fades off when it gets hot, with this guy, we actually get better shock action as we heat it up. Another thing that we're going to want to do to get more performance off-road in our Jeep is we're going to want to disconnect the front sway bar. Now, the sway bar is a part that gives us more stability in turns on the road. But when we get off-road, it tends to slow down our suspension travel from side to side, and it tends to put a little dampener on how much flex we're going to get. In this diagram, I show the exact same vehicle on the exact same course or the exact same obstacle. And you can see that the top picture, the tire's off the ground. Now that one has the sway bar connected. Now on the bottom picture, you can see we have all 4 tires on the ground, and that's with the sway bar disconnected. One easy way to do that is to install what's called a quick disconnect or a sway bar disconnect. And this is going to give you a system that you can pull a couple of pins, slide the link off and store it, and then you go four-wheeling, your suspension can travel its full motion, and then when you're done, you just pop them back on and put the clips back in. If you have a Rubicon, you might have a button that does this electronically for you. I've also known people to just take the bolt out of the factory bar and then secure it up out of the way. And this works as well, just takes a little bit longer and takes some tools and some crawling around on the ground. Some other pieces to look at too are off-road sway bars and dual rate sway bars. There are some sway bars that we can leave connected and still get a lot of suspension travel. Examples of this is going to be like Rock Jock's Anti-Rock or Curry Anti-Rock, Terraflex's dual rate sway bar. This type of sway bar we can actually leave connected, and it will offer varying rates of anti-sway. And with these off-road and dual rate sway bars, we can get varying rates of suspension travel and anti-sway. Some of them are adjustable. Some of them are static. Some of them have a knob that can be disconnected. So what happens when we get stuck? It's gonna happen. If you're not getting stuck, you're not pushing your limits. How are we gonna get out of that? So when we start talking about recovery, the first thing we want to emphasize is safety. Safety of your person, safety of your equipment, this is paramount. We want to use equipment that's designed for the purpose we're using it, and we want to make sure we're using it in the way in the manner in which it's designed to be used to safely recover your vehicle. All your spectators, all the people that are watching, because trust me, when you get stuck, everybody's going to be looking at you. Now they need to be at a safe distance. They shouldn't be in line with any of your recovery straps. They shouldn't be in between the vehicles. You want to make sure your communication system is clear with the person and the people that are helping you get pulled out, and you want to make sure that nobody's going to interrupt that. Another piece I want to talk about is how the synthetic and kinetic recovery systems, sometimes they can require rest time to allow the fibers to get back together and to reduce heat. If you just keep relentlessly pulling on a kinetic strap, you can actually wear out the synthetic fibers and cause it to break. Another thing that I want to think about in terms of recovery and obstacles is the impact on our environment. We want to try to follow tread lightly. We want to try not to tear up the land or put deep ruts in. I like to use the 3-try rule. If you've tried it 3 times and you can't get up, go ahead and pull a strap, and let's not tear up the track and tear up the road. When we're on public lands, this is especially important because as we start to see erosion and as we start to see the track get tore up, that's when the environmentalists come in and start trying to shut down our usage. So we want to make sure that we're responsible, and we want to make sure we know when to call for recovery gear. I can't stress enough the importance of proper recovery points. We need to have the appropriate recovery points that are mounted to the frame through bolts or through factory design that are designed to have the force that we're going to put on them. When we have a metal recovery point, such as a D-ring or a tow hook, if this were to break off of the frame, it will send it like a rocket, and it will kill you, it will hurt you, it will damage your vehicle. Before you hook up a tow strap, before you hook up a winch, you have to ask yourself, what am I hooking it to and how is it secured? And keep that in mind every single step of the way. Another thing I want to remind is we never want to use a tow strap with any hooks on the ends. We always want to use looped tow straps. You should have something that looks kind of like this where you've got a loop on it. We don't want any hooks fixated on this or anything. Tow straps is an important thing to consider. We have several different styles. and not all toe straps are the same. We have toe straps. We have snatch straps. And what are the difference between those? We also have some of the newer recovery gear. We're using the kinetic ropes. Now, you've heard me use the word kinetic a few times, so let's talk about what that means. When we get into kinetic recovery gear, what we're talking about is synthetic fibers that are designed to stretch and then pull back together. So when do we use each one? These two are kinetic recovery pieces. This recovery strap is not kinetic. This is for static pulls. The difference between the two, this one doesn't stretch. This one does. So if we're pulling out a vehicle that's extremely stuck and we're slamming on it with another vehicle, maybe we have to take a little run. This one's not going to cushion that impact. It's going to give it a harsh pull, more like a chain. This one is going to reduce the impact. It's going to stretch. And then the fibers are going to have a natural desire to try to pull back together. So we're actually going to get some additional pull strength from this. One thing to consider here is this. When you start to see little colors show up in your fiber here, you're reaching the wear indicators of your kinetic recovery strap or your snatch strap, and it's time to replace it. That's telling you when it's time to go. When we look at the standard toe strap, if you will, what we're talking about is a piece that's designed for a static pull. That's if you have a vehicle that's on flat pavement or that's dead, that's going to pull at a steady rate of speed and a steady amount of force. Your snatch straps are going to be when you're trying to grab somebody quick out of something like mud or up over a rock. We're going to have dynamic pulling force that's going to change. And this kinetic synthetic materials are going to help cushion that. When you're choosing your snatch strap, you want to choose one that's 2 to 3 times the weight of your vehicle. That's generally where we try to target it, to keep it as small as possible and as lightweight, but still strong enough to get us over most obstacles. Other pieces of recovery gear that we need to talk about are going to be winches, snatch blocks, D-rings, Clevises, and tree savers. So the first piece we want to talk about is our metal clevis or D-ring. Now if you have D-ring mounts or if you're working with a recovery strap, this can be a very handy piece. It mounts in, you slide it over your looped thing, your loop strap, and then you screw it in. You want to screw it in until it's firm. This gives us a closed system where no hook can just come loose and pop off. You literally have to break this in order for it to go flying or to get the energy that a recovery strap or a winch can put on it. One other piece that is really become popular now is what's called a soft shackle. And this can take the place of this metal D-ring that weighs a lot. And that's made out of like winch line. The way this works is you have a loop, you throw it through, and then as you pull, again, you have a closed system that's not going to come apart. You have a choker portion of this that tightens down, so the harder you pull, the tighter it gets. And it's made out of the same material that you're going to hook your 10 or 12,000 pound winch up to pull it. So you know it's just as strong. With this lightweight material, there's virtually no energy stored. So if this were to break or give away, it's not going to go flying and kill somebody. Much safer, and frankly, it's a little easier to deal with. You can loop it, put it on your mirror, hanging off your roll cage, whatever you need. We generally are going to recommend the synthetic winch ropes. I like these because they don't store as much energy. Now we do have a couple things we need to think about. Synthetic winch ropes do not like ultraviolet light. So if we leave it out in the sun all the time, it's going to deteriorate pretty fast. They also have low resistance against abrasion. And so what we find is that we have these little nylon sleeves that are on there. Most people don't really know what that is. It's actually an abrasion sleeve. So if there's a part that your winch rope is going to be touching a rock or something sharp, you want to slide that abrasion sleeve down over it to help protect it and keep from cutting. All of these little fibers and strands that make up a winch rope is what gives us its strength. If we start cutting away on that, that's when they're going to get weak and break. At the end of this rope, there's a couple of different ways we can do it. We can do a hook similar to this, but we've also been listening this whole time we've been talking about how we don't like hooks. What we recommend is something like the Factor 55 pieces that go on the end of your winch rope. These are part of the closed winching system, if you will. We don't have any hooks that are open. Now these are pretty versatile. They replace your hook on the end of your winch rope, and then we can use them a couple of different ways. We can attach a strap whether that be a tree saver, whether that be a tow strap. We can just attach it with a clevis like that. And again, we have a completely closed recovery system. There's nothing to slip or fall off. If it comes loose, something broke. Much safer. Because the D-rings can be sticky and hard to manage at times, oftentimes we'll find that the synthetic soft shackles work much better, a little easier to deal with. Same deal, you just slide the choker end over the knot. We pull, again, we have a closed winching system. The harder we pull, the tighter the connection is. It's not going to break apart. There's several different styles. This is the standard Pro Link. Nice and simple. Only drawback is it sticks out a little bit. For those that like as much of a flat bumper as they can get, we use a flat link where you pull it in, then you flip it to the side and it just doesn't stick out as far. Other than that, they're both about the same. Another critical component when it comes to using your winch is what's called a snatch block. This is a pulley system, and we can use this a lot of different ways. We can send this out to a tree, attach it with our tree strap. Now, a tree saver strap is not kinetic. It's a steady, static pull. It gives a wide base to wrap around a tree. If we hook the synthetic line or a steel winch cable around a tree, we're going to kill the tree. And when we start killing off the trees, that's when the landowners get really unhappy. So we never want to touch a tree unless we have a tree saver around it. Now, the appropriate way to do this would be to wrap the tree saver around, and then we're going to attach our snatch block with either a soft shackle or a D-ring. Then we're going to feed our winch line through it, and we can do a couple of different things. We can go back to our own vehicle and we can increase the pulling strength of our winch. We can also change direction of the pull. We can anchor it and pull from a different direction. And we can actually pull 90 degrees perpendicular if we need to. So it's a very handy piece that allows us to pull from different directions or increase the strength of our winch. Whenever we're working with a D-ring or a metal clevis, the appropriate way to use it is to tighten it down to its finger tight, and then we're going to back it off approximately 1/2 of a turn. That's how we pull on it. Now, we never want to side load something like this. We don't want to hook it in there and then pull sideways. All of our pulls are designed to be from the front. So we want to make sure that our pull's from the right direction. So Axle Boy Off-Road is out here in O'Fallon, Missouri. We do have a large showroom that you can come out and check out parts. We keep a pretty good inventory here for most of your Jeeps, your JKs and your JLs, recovery gear, airing up, airing down, deflators, that sort of thing we keep on hand. All right, well, thanks guys for watching my presentation. I just want you guys to know that we're here for you. So if you have any questions or there's something I didn't specifically cover, please reach out. You can reach out via email. You can reach out via Facebook, axleboy.com. That's AXLEBOY.com. We have a contact form there. Feel free to fill it out. You can also give us a shout, 636-939-5337.